B550 motherboards have taken heavy criticism by many, as they often offer a reduced feature set compared to their X570 counterparts at a similar price, at least with how the market currently stands shortly after the B550 launch. But there's one B550 ITX motherboard that comes in significantly cheaper than the competition, the Asrock B550M-ITX, and that's what we'll be taking a look at today. Coming in $50 cheaper than the second cheapest option, the Aorus B550 Pro AX, we're going to look into why this Asrock B550 board is so much cheaper by going through its features and compromises, running a completely unorthodox VRM test to see if it can handle a mid to high end CPU, and then we're going to discuss the one thing that will cause many of you to unfortunately not even consider this board. So Asrock B550M ITX review, let's do this. So firstly, let's see what you get inside the box of the Asrock B550M ITX before we go over its features and in some cases, lack thereof. You get an I/O shield. Nobody was expecting this to be an integrated shield on a budget motherboard. Next to that, you have the RTFM documentation with a cool Asrock branded coaster inside. You get two SATA data cables, one of them having a 90-degree connector on one side only, a couple basic Wi-Fi antennas that are nice and compact, and then the motherboard itself, which looks both monochromatic and utilitarian. Being a budget motherboard, we don't get any elaborate heatsink designs or RGB elements built into the board. Don't worry, it does have RGB headers and we will get into that in a bit, but this is a design that I do appreciate as it will suit most builds. So before we have a look at the VRM solution and the one specific thing that might turn you off this motherboard, let's go over the major connectors you get and what you can plug into it, as this tells us a lot about the features and also what you're missing compared to more premium B550 ITX boards. So starting bottom left of the board, you have the front panel audio and internal speaker connector, which then takes us all the way over to the right where the majority of the connectors live, including a 4-pin PWM fan header and a clear CMOS jumper. Next to that, we have a nicely labelled front panel header sat above your USB 2.0 connector, and we also get a single USB 3 Gen 1, 4 SATA ports and your 24-pin power. At the top of the board, you get two 4-pin PWM fan headers and two 50/50 RGB headers, one 4-pin non-addressable and one 3-pin addressable header, which leaves us only with the connector for the BIOS battery and the CPU 8-pin EPS connector. So taking a look at the rear end, this is where we start seeing some of the cost-saving measures. You get the typical HDMI and DisplayPort connectors, 5 USB Type-A ports and a single USB Type-C. You also get a PS2 combo connector and a 3-line audio solution. As for networking, there's gigabit Ethernet and dual-band Wi-Fi. So what this tells us is that there's a few features missing compared to more premium B550 ITX boards. For internal features, you're only getting two fan headers other than the one for your CPU. And you also don't get a USB 3 Gen 2 header, used for most cases with USB Type-C front panel connectors. But honestly, these may be pretty minor things to most people that can easily be resolved with splitters and adapters that I'll drop in the description for you. But as for rear I/O compromises, there are a few. Number one, this is currently the only B550 ITX board that doesn't have 2.5 gig Ethernet, and there's a similar story with the wireless chipset 2, being the only one that doesn't utilize Wi-Fi 6, while also implementing a slightly lower tier audio chipset. So most of the money that you're saving here, and whether you need those features or would rather invest that money elsewhere in your build is entirely up to you. So let's test the thermals of the power delivery quickly before we take a look at the biggest compromise and what might turn you off this motherboard. So the B550M ITX has a decent 6+2 phase 50 amp power stage solution, but the biggest concern is this tiny heatsink. It does sit 29mm away from the edge of the socket and only sits 18mm tall. So those using downfiring coolers, rejoice, you have great compatibility. But because it's so small, I think it's especially important that we test the VRM thermals. The only problem is I'm not getting any VRM sensor readings from hardware info, which could be for a couple reasons, but it's most likely because being a budget motherboard, Asrock have decided not to implement a sensor. So we have to get creative, for which I have an egg. So we're going to stick thermal sensors on heatsinks, load the system, record what we can, and try and cook an egg for science. So let's do something stupid. Okay, our probe has leveled out at 70 degrees here, and this probe is on 52.5. So let's do the stupid thing. God, this is such a bad idea. Oh, it's so stringy. That is a decent amount. Okay, let's come back in a few minutes and see if it's cooked. It's definitely turning white, but I don't know if we'd consider that to be cooked. I guess the test is, would I eat it? And the answer to that question is no, I definitely wouldn't eat it. So this test was using a 3700X running stock with no airflow over the motherboard, kind of a worst case scenario. We saw 70 degrees on the temperature probe attached to the VRM heatsink, and more importantly, we didn't cook the egg. But talking real numbers for a second, if we compare the results of the M.2 sensor and its thermal probe, we have a 2.5 degree delta. So we can make some assumptions based on thermal load and heatsink size for the VRM. And in my opinion, the VRM on this board is absolutely fine for most people. Current 8 cores and likely future more power efficient 8 core CPUs look to be handled really quite well. And you probably could go even higher core count with decent airflow, but I feel like most people wouldn't be pairing a budget motherboard with a $400 plus CPU. It just doesn't make a ton of sense. But in comes the curveball. As with all B550 motherboards, you get guaranteed full Zen 3 future compatibility for Ryzen 4000 CPUs, as well as PCI Express 4.0 connection to both the top and only PCI slot in this case, as well as one of your M.2 slots. This allows for double the bandwidth compared to PCI Express Gen 3, supporting high-speed storage and compatibility with upcoming Gen 4 devices. Which brings us on to the biggest compromise of this motherboard in my opinion, the single M.2 slot. With a lot of people moving to solely M.2 storage, this board only having one slot compared to its competitors may be the reason many people never even consider this board. And I think it's such a shame, because otherwise it's an incredibly well optimized board, giving you what you need and nothing more, allowing you to really invest a bit more into a higher tier GPU or CPU. But if you see yourself only buying a single M.2 drive for everything, or using a 2.5-inch drive for your secondary storage, and would rather save a bit of money, this might just be the motherboard that you've been looking for, and I'll drop a link to it in the video description for you. So if you enjoyed this review, get subscribed, turn on notifications before you go to make sure that you don't miss upcoming TechLens content. Otherwise, a like is always appreciated guys, and I'll see you in the next one.